Alright, so hello everyone, I'm Adam and today I'm going to be going over dclimatevision, which is a tool that I've been working on for visualizing and dashboarding data from the dclimate free API. And so for context, dclimate is a decentralized protocol focused on bringing weather, climate, and environmental data to your applications and your decentralized applications. And so dclimatevision is available at the very pretty URL that I'm proud of, the dclimate.vision. And so today I'm just going to be going over the tool, what you can do with it, and just some examples of how it can be used. So for context, as we sort of load in, we can see our first portion of the user interface is going to be focused on selecting our user inputs for the data that we want to get and what we want to do to it. And then underneath, we're going to have our plot that's returned. So to start off with, we can pick whether we want to just plot a raw element, which means just getting our raw data from the source as is, or we can pick if we want to do some analysis to this. So for now, we'll just leave it as a raw element. Then the first thing we do is just pick what kind of data we want to analyze, and then we pick whether we want to do a secondary element or analysis or not. So in this case, we'll just leave it as no, we'll just do one. And then the final thing is we have an notice whenever our query is not complete. So if there's not enough stuff to get a plot, then we're going to be told it's an incomplete query. So to start off with, these are the data set types supported, and some more will be coming. But let's just go in with the very first one. So as you can see, our user interface updates to whatever data we want to look at. So in this case, let's just say we want to see the data from our first CME station. So as you can see, once we filled out all the parameters, this get plot button appeared, and then when we click get plot, we go into our loading screen and we get back all our data. Now this plot is generated with Plotly, so it has some sort of functionalities built in. Like you can download it as a PNG if you want to save it for later, and then use all these different tools. So you can zoom in on the data, you can pan through your data set, and then you can just auto scale back to the original parameters and zoom in and out. And so that's just some nice features that you have with Plotly. Now, as I said before, we have 5 different data set types supported. So we have the CME stations, we also have the Dutch stations. So these are also station-based data sets, which take in a variable and a station number. Now, the GFS forecasts are also supported, but when we click on GFS forecast, we get some different parameters because these are going to require different things. So let's say we want to see the maximum temperature. Then what we have to do is we have to pick a forecast date. So the forecast is generated every day, and so we need to pick a specific date that we want to get the forecast from, and then some latitude and longitude. And once we pass all that stuff, we get the forecast that was generated on, in this case, March 1st. Or I guess it was generated March 2nd, but there's some time zone difference between them. Then the other data sets we have are the GHCN, where you have to put a GHCN station number, which I don't know any off the top of my head, so I'm not going to do that. And then the grid file data sets, which are also lat-long based data sets. So this is sort of all the different data sets supported, and this is just simply doing the one element, raw element plots, and so that means that we're just getting the data from the API without any analysis applied to it. Now the other thing we can do is we can plot get two different plots, I should say. So let's say we do this. Now we're going to get the maximum and the minimum temperature from the same station. So you can see we get sort of as we expected these two plots, and what's interesting here is it shows up in our title telling us our 2 data sets that we're using, and in this case we're using the same axis for both, so we only see one axis. And that's fine when we're dealing with temperature, because temperature in both cases is measured in Fahrenheit. But for example, if we're comparing temperature and radiation, it's not really good to be using one axis, because the maximum on temperature is less than 100 and the maximum on radiation is less than 3000. So that's why we have this use secondary axis plot. So what this lets us do is compare different data sets with different units and still get comparable plots, so we can look at the sort of trends between different data sets. So that's an example of just getting 2 plots, and let's just go back to getting a single plot. Up until now, everything we've been doing is with this raw element, so let's just do some analysis of an element. So we have these 6 different analysis types supported, so we can get histograms, interval scatter plots, simple moving average, and show extrema. So let's just go through them. To start with, a histogram takes as an input some interval, so like daily, weekly, or monthly, and in this case it's monthly, and then what it does is it buckets the data according to that and either sums or averages the data. So in this case we are summing it, so we have like a 2000 sum for May, 2058 sum for June, and so on. And then if we switch to average, the structure of the graph is pretty similar, but instead of being summed, it's averaged over the interval. And then if we want to get the same data that we're getting from our histograms, but we want it to be represented in a line chart, that's where we use the interval scatter plot. So this is the same data, but it's in a line chart. And if we get averaged, it's averaged data. And then our next thing is simple moving average. So this is gonna take as an input a specific number of points. So if we pass 30, then because this is a daily data set, this is going to be like a 30-day simple moving average. And we get our data with a lot of the noise removed from it. And then our last thing is what we call show extrema. And so for context, I just want to show the original data set so that the extrema will make a bit more sense. So I'm going to, on the primary data set, have our data set just as it is, and then on our secondary data set I'm going to show extrema. And I'm going to pass an n of 30, and then I'll explain what this is doing after we get the plot. So this is a tool from signal processing, and what it does is that essentially you give it a point, a number of points, sorry, like 30, and then what it does is for every point in our data set, it goes n, so in this case 30, in either direction, and it sees if that original point was a maximum or minimum. And so if a point is a maximum on a 30 in either direction in point interval in this case, then it shows up as a local maximum or minimum, and we get this dot on it. And so this lets us see the extremes of our data set, and if we pass a smaller number, then more extreme values are going to show up because it only has to be on 20-point intervals. And if you pass a big number, then we get a lot less points. And so this lets us quickly, at a glance, see the most extreme values of the dataset without necessarily seeing all of the underlying extreme values. And then so now I just want to quickly go over some plots which were generated with dclimatevision to sort of give an example of the kind of stuff you can get. So in this case what we're doing is we're comparing the simple moving average plot to the interval scatter plot for the same dataset, and you can see they're both ways of removing noise from data, but they perform differently. You know, the simple moving average is a bit lagged behind, but less prone to the spikes throughout the data. Now this is a really interesting one where we're comparing the hourly historic data with GFS forecast data. So I think this is really cool because what you're doing here is you're, saying this red graph of the forecast data was generated on February 28th or whatever day this corresponds to, but then this historic data was obviously collected and generated after the fact. So what we're doing is we're comparing this forecast to reality and seeing how accurate it was. And you can see it was pretty accurate, had pretty good performance for this latitude and longitude. Now here what we're doing is we're comparing two different data sets, the CPCC precip dataset with the PRISM-C Tmax datasets, and we're representing our temperature with this line chart and the precipitation with a bar chart histogram, and using the different axes, and we can easily compare the trends for these 2 years for these two different datasets. Then this is an example of the extrema dataset which we were just looking at now, seeing the extreme of a data set. And then this, I think, is a cool sort of suggestion of the usefulness of this kind of stuff. In this case, what we're doing is we're comparing the simple moving average for the data set to the extrema for the data set. And so, you can do this and then quickly at a glance start to understand, okay, with this weather data set, what level of deviation from the simple moving average is expected. And so, in this case, we can see about 20 degrees of difference between the extrema and the simple moving average on that given day can be expected with this data. And it sort of gives you a range for how extreme, how anomalous, how big of an outlier you can expect on a given season, and start to help you understand your data and the trends of it. So that's just some quick 5 examples of stuff you can get with dclimatevision, but really whatever you want to do, it's sort of up to you with this tooling. Now I just want to mention one thing quickly before I finish off. This is a Dash application which is hosted on Heroku. So it's available at dclimatevision and it's hosted on Heroku, but there's certain limitations that are introduced while you're using it hosted on Heroku. So for example, if you try to get the hourly datasets, it currently takes most of the time more than 30 seconds to query an hourly dataset. And Heroku has a 30-second timeout, so you don't get the data from those hourly datasets. So if you want to generate plots for the hourly datasets, that's completely fine, but you have to run a local version of the dclimatevision app on your own computer, at least for now. Like eventually I'd like to support longer than 30-second queries, but for now, if you use Heroku and you're just getting no data back for like the hourly datasets, for example, it's probably because you don't have, it's taking too long and you're going to need a local version. And so if you think you need a local version, just reach out to me. I can get you set up with it, but the repo's available here, all the code's there, and yeah, anyone can tinker with it and do whatever they want. And so yeah, this is a sort of user guide for the application. Just let me know if you have any feedback or anything. And then I'll probably make like a more technically oriented like code guide in case anyone wants to play around with this a bit later down the line when the sort of code is more well organized. But I just wanted to get this out first to see if anyone has any feedback on this. And yeah, that's pretty much all I wanted to go over. And thank you for listening, and let me know if you have anything to say.